Welcome to the Interop. Today my guest is Bo Du. He's technical lead at Polymer. They're building Ethereum's interoperability hub. Today Bo's back on the podcast to talk about Polymer's recent shift to the OP stack. That's right, they're no longer building a Cosmos app chain secured by Cosmos validators. They're building a chain that will be secured by Ethereum and will sit on the OP stack. This was announced just a couple of days ago at IBC Summit in Istanbul, so it's pretty hot alpha. We'll talk about why they decided to do this, why they decided to move to Ethereum. We'll talk about how Polymer enables IBC for EVM rollups. We'll get into the technical details about how this works and how it changes the architecture of the platform. And we'll discuss the Monomer SDK, which is a Cosmos SDK for the OP stack. I'm also dying to find out why he thinks the real merge is the convergence of Ethereum and Cosmos. I also tend to think that. So before we get started, make sure to subscribe to get notified when new episodes drop every week. And remember that none of what we discuss here on the Interop is investment advice. And quick disclaimer, I am an angel investor in Polymer. And if you enjoy this content, please consider staking with us. We're validating on Evmos, Quicksilver, Osmosis, and Juno. Just look for Interop in the active set. My guest, Bo Du, is coming up right here on the Interop. Hey, Bo, thanks for coming back on the podcast.
Yeah, glad to be back.
Yeah, so actually, I mean, for the audience, like we saw each other just a couple of days ago because we were both in Istanbul. I've came back to Paris. You're still in Istanbul for Dev Connect, and you guys hosted IBC Summit, which I think was like the fourth or fifth one or something like that. I gotta say, like, lots of great content at this conference. I thought like it was very technical, very in depth, a lot of really great conversations around the panels. So yeah, why are you guys doing IBC Summit, and what's the long-term vision for this conference?
Yeah, I think everyone in the Cosmos space is generally like aware of IBC. Maybe they don't know exactly how it works, but they know of the technology and are generally like, this is the right solution for interoperability. Whereas on the Ethereum side, I feel like there isn't a coherent long-term vision for interoperability yet, or a story there. And especially kind of like Ethereum's roadmap is like scaling focused, and rollups need interoperability. They need to be able to talk to each other and ideally be interoperable or natively interoperable with other existing networks like the Interchain and the Cosmos. So the goal with IBC Summit is to I guess like educate, like first and foremost, and two, kind of like spread the word about IBC and help these other ecosystems understand the power that IBC has and why it makes sense as a unified interop story, not just for the Cosmos, but for other ecosystems. We did one at Breakpoint for Solana. I know Solana, I guess his thesis now is like they don't need rollups, they don't need sharding, but at some point, like they will be interoperable with other ecosystems, and we want to make the IBC that story as well.
What was the response to IBC Summit at Breakpoint?
Yeah, surprisingly, we had like quite a number of attendees, like more than I thought, because I just assumed that Solana people just weren't interested in interop. And the response from the more technical community was that, like, even though the marketing right now is more like, oh, only possible on Solana, or like everything can fit on the L1, I think in general the technical community does agree that at some point Solana could potentially be a settlement layer. Solana could do other things like DA. People are talking about like Solana doing DA and other sorts of things as well. So it's possible that Solana, and also this investment in Solana Light client development. So there's definitely a path forward for IBC in the, I guess, like medium to long term future.
Wow, Solana being interoperable with other chains. Can you imagine what that would look like? We could just use Solana for everything. I mean, all chains would just settle to Solana. Ethereum could settle to Solana. The Federal Reserve and all of Visa and MasterCard and all the world's central banks, and even everyone's thoughts and ambitions can settle to Solana, because Solana scales infinitely. So you guys actually announced, which honestly I thought was surprising. I wasn't expecting this announcement, but you announced a sort of shift in strategy for Polymer. Now, you were on the podcast. It was just a couple months ago. It was like in June, but I thought like let's do one now. It's like, for everybody listening, this is like hot alpha. This has not been discussed anywhere else but at this conference, as far as I know. So, what led to this shift in direction?
So before I actually talk about what we're planning, I would say that for the longest time, we've been thinking about how to get the best distribution for the IBC technology and in general, like Cosmos tech. I think like every ecosystem's builders generally respect the Cosmos ecosystem, respect the builders, the thinkers, the researchers, the all of the ecosystem participants as well. And in general, we kind of see other ecosystems borrow ideas from the Cosmos, but not necessarily have distribution for the Cosmos tech. So it's like, oh, Cosmos has great tech, bad distribution. So like we wanted to solve the distribution problem. And then on that front, I would say that the initial approach was to build an IBC connection with Ethereum. And after we did some, I guess like we're chatting with folks and I'm thinking about this problem, we strongly felt that the IBC connection alone would not be enough. So like just chatting with Ethereum folks, I feel like if you talk to them, they'll be like, yeah, I've heard of this IBC thing, but they're kind of like grasping at like air or straws. It's just like I don't know what it is. It's just like somewhere in the cosmos, and like I
In the
can't see it.
ether.
Yeah, in the ether. It's like I cannot see this technology. I cannot feel it. So like um, the connection alone, and also like the trust model of the connection, which I'll get into a little bit later, uh, also means that like you have to put something in the middle. Like it's not ideal to have this thing in the middle. So we're thinking, and also like this would only be an IBC connection alone. So we're thinking like what would be a better way to get distribution for the Cosmos and IBC tech? So the shift here is that we're no longer building a Cosmos SDK like app chain or a sovereign app chain. We're actually building an app rollup. So we've combined the Cosmos SDK and the OP stack and merged them together because we felt like this was the best approach for getting distribution for the Cosmos tech itself. Since now it's not just like the ideas being borrowed, the literal like modules that builders are working on can now be plugged into Ethereum or the Ethereum ecosystem directly. And the other idea is that as an interoperability hub, if we want to do interoperability across Ethereum rollups and like kind of like bring this IBC technology to Ethereum rollups, the best way would be to build it directly on Ethereum as a rollup. You inherit security from the Ethereum domain. You can have like rollup to rollup communication with IBC semantics with Ethereum level security. So it's native IBC interoperability with Ethereum security. Going cross domains another thing, but within the Ethereum domain itself, this is what I believe to be the most scalable, like long term approach to interoperability across like all these different rollups in different ecosystems.
Okay, so maybe just to summarize here, so when you were last on, the idea was Polymer would be a Cosmos zone, a Cosmos SDK chain with validators, as we know, right? But
Mhm.
that zone would create an IBC bridge to Ethereum,
Yes.
and possibly other EVM chains and rollups, but at least one bridge to Ethereum. And then once you're on Ethereum, it's like, yeah, all right, now what, right? Like, how are you gonna bridge over to Polygon and Arbitrum and Gnosis chain? And I think
Yeah.
that was a little bit like still up in the air, at least from what I
Yes.
remember.
Yep.
Now it's sort of like shifting the position of Polymer, and Polymer it's embedding itself within the Ethereum ecosystem by becoming a rollup.
Mhm.
Not only providing an IBC connection to the Cosmos, so it's sort of like the other way around right now. It creates an IBC connection to Cosmos via Ethereum, where in Cosmos everything's already IBC, so you don't need to worry about the interoperability once you're there.
Mhm.
But by sitting inside of Ethereum, it can provide IBC connectivity with other rollups. So it effectively creates like an IBC hub inside of the EVM space where all the rollups can interoperate with Polymer in the same way that the Cosmos hub interoperates with all other Cosmos chains via IBC in Cosmos. Polymer is kind of like this IBC hub in Ethereum. Is that a good representation of sort of the high level vision here?
Yeah, absolutely. And that kind of brings me to like using like a high level analogy here, and I'm kind of stealing Ethan Buckman's article from Sam Hart's article from a number of years ago, describing the Cosmos Hub as a port city. And I think that's an accurate description. I think also it's relevant too because IBC actually uses this port concept. You bind like applications to ports, and you can create like channels between them. So in my mind, it helps Polymer establish itself as a port city for trade, similar to the Cosmos Hub, but in the Ethereum space. So the analogy here is that uh, a port city is as secure as like the country that it's sitting in, if that makes sense. So like if you know you're a port and you're sitting in the U.S. perhaps, and this port gets attacked, then the U.S. will defend this port with its military. And in the same sense, like a port docked in Ethereum, a port city docked in Ethereum is defended by Ethereum stake. So that's just like my mental model for it. And then in like each country, you have different port cities that like talk to each other, if that makes sense. So like the port cities act as like the lanes of like global commerce, while within the Ethereum ecosystem, the port city can also facilitate the transfer of goods between all the different cities within Ethereum itself. If that makes sense. Like if all
Yeah, no,
like the
absolutely
yeah
makes sense. Yeah, yeah. I mean, I think that this port city analogy is quite apt. Like Sunny's also talked about this too, right? In terms of security,
yeah
geopolitical security and like the military industrial complex seem to be a good analogy for a lot of things in blockchains.
yeah
Um, so I'd like to maybe just take a little quick step back here before we get into the
okay
details here. So a little kind of quick refresher on IBC, which will color a lot of this conversation. So last time you were on, you described IBC as like two parts, right? There's the transport layer and the application layer, and Polymer creates this unified transport layer for IBC.
Mhm.
With regards to that, when thinking about connecting different EVM chains to IBC, what does that transport layer look like? And are we still thinking about having individual applications for individual types of activities on chain? So, for instance, if we look at IBC on the Cosmos side, you have applications for token transfer, you have applications for shared security, you have like all of these are the applications of IBC. Now,
Yep.
those don't necessarily carry over perfectly in Ethereum. We might have like a token transfer application, but maybe shared security is different, and maybe there are some use cases, maybe some applications in Ethereum are different just because of the way Ethereum and Cosmos are different. So how does Polymer sort of sit there in the middle, ensuring that these applications are compatible with each other, right? So if you're making a token transfer in Ethereum, it will get understood on the Cosmos side.
Yeah. So, like the tokens themselves on Ethereum side sit in a smart contract. The tokens in the Cosmos side, the balances sit like natively in the chain itself. So, like that's I think one of the big distinctions. There's like this concept of like escrow accounts that doesn't really exist in like EVM like smart contract land. Those technical details aside, I would say that when people think of an interoperability API, like like standardized interoperability API, the standardized point is at the transfer layer. Just so we're clear here. So like if you look at TCP/IP in the OSI networking model and IBC in the interoperability model, we see that they kind of sit in a similar place. They expose a similar API, which is like you get some data packets. What those data packets mean, I have no idea. But you as an application go figure it out. And you implement some features. So yeah, Palmer just does that. So it makes sure that the like below the bytes level. So once the application has composed some bytes, that it is transported between the chains, meaning that you have to enforce all of the messaging rules so that you can enable features like acknowledgements, timeouts, and so on in a standard way across all of these connected chains. Above that level, so like in terms of compatibility, the you can create like ICS 20 like smart contracts that essentially enable communication in a single lane. So I kind of see like IBC channels as lanes in a highway. So like a IBC connection is a highway. Um, and these are application specific lanes. So it's like a lane in a highway that says only cars of this type, like only motorcycles, or like only like buses. And you kind of see these lanes on the street, or like only bicycles or only pedestrians. Um, and for the ICS 20 contract, because it gets bound to a channel, the thing about ICS 20 that I think is like relevant in my mind is that the main difference is that you have fault isolation on a per channel basis. So for your application, for the security model that you have picked, which in the modular security world, security is non-fungible. Like whether you used whether you verified
Yeah.
consensus between two chains, that is not fungible with a Chainlink oracle or some sort of off-chain guardian set observing this. Like these are two different things. Um, and because these are non-fungible, you have fault isolation on a per token basis. So like between I guess this like token contract on Ethereum and maybe like a token like the I guess like ICS 20 module on the Cosmos side, between those two, where like kind of Polymer enables this connectivity, you have this like lane that is untouchable by any other types of transactions. It's only token transfers between the two. And generally, this is not how other interoperability protocols work, especially in the Ethereum side. It's like you spin up a token contract, you give it access to some sort of like gateway or importing contract that the other interop protocol has, and it's just one fat lane for everything. And it's and it's like it's just a lot going on. You kind of have to do all these checks and balances for yourself.
Okay. Yeah, I see. Um, let's transition then into the OP stack and Polymer. So Polymer is going to be a roll up that leverages the OP stack. It was interesting because when you announced this just before, I was at like this Optimism event, learning about Optimism and the OP stacks. Like I admit I don't know a whole lot about the OP stack, so maybe it'd be helpful to start with an overview here of what exactly is the OP stack and what's this concept of a super chain. And
Yeah, so I think the marketing of OP Stack is very like kind of like similar to the marketing of the Cosmos SDK and the interchain. So it's like Cosmos SDK, build your custom app chain, be a part of the interchain. And with OP Stack, it's like build your app rollup and be a part of the super chain. The marketing is very similar. So let's get into technicals.
is the super chain kind of akin to the Cosmos Hub here in terms of shared security, or is it not?
So in the super chain model, I guess the Cosmos Hub would be Ethereum.
Oh, okay.
And like the app rollups would be like ICS secured, like interchain security secured chains, except they use like a settlement mechanism instead of using I would say like a shared validator set, I guess, with the interchain security model.
Okay. Yeah.
So like to me, like ICS and like Eigen Layers, like active validating services. So like restaking secured services is like similar to interchain security. And the settlement model is a little bit different. But yeah, like at a high level, it's like the hub and Ethereum, the L1 are like the same. The hub is the heart of the interchain, and the ETH L1 is the heart of the superchain.
Okay. And then applications use the OP stack to deploy rollups, and these rollups can be VM rollups. They can be Cosmos SDK. They could be like a move VM. Like the type of rollup, the type of VM isn't like the OP stack doesn't prescribe the VM, right?
From the marketing perspective, yes, and I think that is the intention. From a technological perspective, I would say it's a lot trickier to integrate just some random execution engine into the OP stack. We're in the process of doing that. Um, the problem is that the engine API. So the ABCI, they try to kind of make it generic between like some random state transition function or application and some random consensus mechanism. For the engine API, they're also trying to serve the same purpose. It serves the purpose of separating the consensus layer actually of the Ethereum L1 of the Ethereum L1 from the execution layer of the Ethereum L1. When they did the migration, or when the Ethereum went through the merge, the original L1 became the execution layer, and they overlaid on a consensus layer network. And the Engine API actually is what separates the two. So Engine API, ABCI, those two interfaces serve the same purpose. The Engine API is somewhat generic, although there's a lot of like the only current execution engine that's like natively supported in the Cosmos SDK code base is OP-Geth, or like OP's slightly modified version of the Go Ethereum client. There's a lot of like ETH-isms like in the OP stack. So like if it were like completely generic, it would be seamless to just plug in anything. As long as you like implement this interface, you're done. Like you never need to cross over into the OP stack and change anything. However, there's a lot of places that expects like an Ethereum block, and like I mean, it should be kind of obvious. Like a Cosmos SDK chain does not produce an Ethereum block. There's like a whole bunch of fields and like things that just don't make sense in the context of a SDK app chain. So there's quite a bit of work to make them compatible.
Okay, we'll come back to the technical bits here.
Yeah.
But yeah, first, like, let's talk about uh, what this roll up like. So this roll up that we described earlier that sits in Ethereum. How will this roll up interact with other? How will this roll up implement IBC with other roll ups like Arbitrum or Optimism,
Mhm.
or you know maybe also, like, I mean, will it interact with, say, other EVM L1s? It's like, for example, the Gnosis chain. I think I would consider that to be more of an L1 because it has its own validator set, although I believe it does do some kind of like shared settlement with Ethereum.
Yep.
Yeah, how will that all work?
So Polymer itself, the functionality has not changed necessarily. So the original idea with Polymer is that it's difficult to expand the IBC network. So like the main blocker with expanding the IBC network was it's difficult to implement IBC. So like it takes time, and also you have to convince this other chains like developers to say, please put this on your roadmap, or like I created this PR for please upstream this. And if they don't do it, then you get into the cycle of they keep changing their code, and then you have to kind of keep this like update up in sync with their updates as well. It's a long process. You have to get buy-in. There's this is not permissionless. This is very much a permission process to do that. So the idea of Polymer was like, Polymer was trying to answer the question of how can we expand IBC permissionlessly? And to do so, we created an internal protocol called virtual IBC. We essentially represent the chain that's connected. At a high level, what it does is it says that like the question that it answers, like, do you need to execute the IBC logic on the original chain? And what we realize is that like you actually don't need to do that. You can have Polymer as an interoperability hub take on that responsibility for you. So you still form this connection in like a logical sense between this I guess rollup and Polymer, except the rollup doesn't execute the IBC logic. Polymer executes the IBC logic on the rollup's behalf, and what sits on the rollup is a smart contract. That smart contract acts as an interface. There's only the only points at which the rollup's application code and the IBC interface are at the channel level and at the packet level. So you have the concept of a channel lifecycle and you have the concept of a packet lifecycle. So when an application calls into either a channel lifecycle method or a packet lifecycle method, these calls actually get propagated to Polymer, and it gets validated using the same kind of like bidirectional client logic. So there's still a connection. There's still a bidirectional client. In this case, Ethereum is the verifier. So like you're not saying that you're verifying like rollup A or like rollup B is verifying each other's consensus. There's no consensus for rollups. The rollups are settling onto Ethereum. Each rollup has, I would say, like trusted access to the L1 state itself, meaning that every rollup's blocks are derived from the layer one state, if that makes sense. So like there's no like we don't need to verify Tendermint consensus. We actually don't even need to verify Ethereum consensus. We already have access. We already have like the state of Ethereum for free. So with this client verification, which is very, very trust minimized at this point, like you're basically just using the L1 state. You can say that I observed some transaction happening on this rollup to call into the IBC logic, and you bind the call. So now the call is asynchronously bound to the IBC logic in Polymer, and then Polymer now forms a connection outwards to another rollup. So you can either have like a connection, connection between like a rollup in Polymer and another rollup, or you can have a connection between a rollup in Polymer and back to the Cosmos. Now you can imagine like if you're a DYDX or you're a Gnosis chain or some other chain that's not, I guess, like IBC compatible, you can still have connectivity, IBC connectivity to Ethereum rollups over Polymer over these connections.
Okay, yeah, this is starting to make sense. So Polymer, so contrary to like so in Cosmos, you have like a chain that initiates that sends a message, let's say for like a token transfer.
Yes.
That chain sends a message to the other chain. There's
Yes.
like the tokens are escrowed. That chain sends a message to another chain via a relayer. That the other chain receives that message, and then a validator will do a light client verification of the other chain to make sure that those tokens have been escrowed, and then sort of issue the tokens there on that side. And so both chains are interacting with each other in that sense. Whereas here, chains are interacting with a smart contract, and then is serving as the intermediary that is that is checking the state of Ethereum. That's checking, let's say, with a light client, the state of Ethereum,
Yep.
verifying that there's been a commitment on, say, like the sending chain, and then send a message to the receiving chain that commitment has been that you've verified that commitment. And so it's acting as a trust layer between the two interacting chains by leveraging like the security of Ethereum that we get for free.
So I wouldn't say Polymer is a trust layer. So like there's no trust in Polymer here. The trust is actually just in Ethereum. Polymer just implements IBC as a feature. So like Polymer is more of like an IB, like a feature layer, if that makes sense. It's like
Okay.
Polymer is adding IBC as a feature to Ethereum and its rollups. The trust layer is Ethereum. So even on
Right.
the yeah.
So sorry, trust layer maybe was not the right. So but as a I mean, Polymer's role is to provide this feature of attesting to the validity of these transactions being settled to Ethereum. I guess why like why wouldn't chains be able to do this themselves? Like why couldn't chains? I mean, I guess Polymer sort of like creates this function, right? It creates this feature.
Yes.
It creates the functionality, but if chains all got together and said we're going to implement IBC, they could do this without Polymer. They would just have to sort of agree on the way to do it, right? They would have to sort of
Yeah.
like, but they could potentially do it without Polymer providing that feature if the entire EVM ecosystem sort of like agreed on a standard way to do this.
Yes, and that would be ideal. So like ideally, us bringing the technology to Ethereum, that they kind of see the power of it, and a lot of these roll up frameworks decide like, you know what, I want to implement IBC. Like I think IBC is the right thing to do because what a lot of these roll up ecosystems are doing right now is they're implementing their own like random bridging protocols, and
Yeah.
that's just going to create more fragmentation. And in this world, there's two options here. So then now, like in this world, where let's say everything has IBC, IBC is everywhere. If IBC is everywhere, then what Polymer serves as is a routing function. So it's like, does it make sense to connect directly? If it makes sense to connect directly, then some chains will connect directly. If
Yeah.
like the chains aren't always necessarily required to connect directly. If there's like millions of rollups, will all a million rollups connect directly? Not likely. Like some rollups will decide like, oh, you know what, I'm just going to connect to an interop hub, and like the interop hub will provide me connectivity to everything else.
Yeah. No, I think it's useful to have hubs, and I think
Yes.
Polymer can carve out a position as an important hub, like a port city, right, between
Yeah.
the Cosmos ecosystem, and Ethereum from this perspective. When it comes to when thinking about uh, in our last conversation we were talking about sort of like some of the challenges of implementing IBC between say a Cosmos chain and Ethereum, and that was this finality, this issue with finality where Cosmos has single slot finality, Ethereum has doesn't have single slot finality, and
Yeah.
so it that's one of the reasons why it's difficult to validate to sort of like verify the state of Ethereum and have like an atomic sort of style transaction.
Yeah.
For rollups that have a like optimistic rollups that have a fraud window,
Mhm.
how is that going to work? Do we run into sort of similar issues here where potentially a fraud proof being issued like later would cause some issues in terms of transactions being verified?
Yes. So if there's a rollback, then I'll say like the entire view will have changed, and that is a risk. So Ethereum rollups have this concept of different rollup heads. It's something that like Cosmos folks aren't probably like highly like unfamiliar with, and they have this concept of like a safe of an unsafe, safe, and finalized head. So the unsafe head is where blocks are just being produced. So you send some transactions to a rollup, they produce some block. That block is not associated with an L1 block, which makes it unsafe. There's a safe head, which says, okay, this block actually, the block data has been published to some data availability layer. And like the definitions here will change in the future with like kind of more modular chains. But it's confirmed that the DA has been made available. And in the Ethereum context, it will also confirm that like at least one checkpoint has passed or one justification, which is part of the Ethereum consensus algorithm. And the finalized head actually checks that like two checkpoints have passed. Ethereum's view, the L1 view, is finalized, and this is at the point at which the rollup inherits reorg resistance. So now this view will never reorg, but it doesn't stop it from being invalid. So if the view is invalid and a fraud proof is submitted between that point and I guess the end of the fraud window, then that view will change. Either it will freeze or you'll do something to this. So there's still the problem of on the like I said Cosmos side, they would need to still run an Ethereum client. So the trade-off here is we're focused mostly or more on rollups for now, just kind of getting connectivity across them. Going to the Cosmos, you would still need the Cosmos chain to run an Ethereum client. So to verify that Ethereum consensus is a certain has been validated, and then you would also need proof that Polymer will verify the fraud window for all of its connected rollups. For the IBC client here in this context, if it's an optimistic client, you have to configure some I'll say like acceptance period. So like maybe you don't want to, if you want to wait the full fraud window, you can do that. It will be a lot more secure. You're just waiting. Like it's just going to be a very slow connection. It's like you send something, it's going to take 7 days. Um,
It's like 56K modems for blockchains.
yeah, yeah. But you can have like soft pre-confirmation mechanisms, either from like using the sequencer signature itself, will or like the sequencer pre-confirmations themselves. That will kind of allow you to get faster connectivity, but then you're trusting the sequencer. So the trust model is like not ideal. Or you can kind of have like a smaller fraud window where you can say like I'm okay with waiting a day, waiting 3 hours, like some configurable level of security there. And the other approach that we've thought of is you can have like an AVS or like active validating service on Eigen Layer validate or act as a pre-confirmer of the rollup itself and attest to validity. So like once data has been made available, which you'll know this information with high security, you also will know with the security of the AVS that that execution was correct. So you can kind of balance like these two things and check these two things to know that I got a message.
Okay. Um, so for in this context, uh, a Cosmos chain receiving tokens from like an optimistic rollup the
Yeah.
Cosmos chain would have to run a client, or would could Polymer serve that purpose? Because I mean, then it sort of like creates this extra burden on Cosmos chains to have to run this extra
Yeah.
client, and potentially, every chain has to do this if it's connected to Polymer.
Yes.
Could Polymer give some sort of assurance to Cosmos chains, or like take on, or like could some other actor take on the risk? Um,
Yeah.
uh,
I think it
yeah,
could be the Cosmos Hub. I think the Cosmos Hub could run an Ethereum client. This kind of makes good on like the Cosmos Hub being the port city for the interchain, and Polymer can focus on being the port city for Ethereum, if that makes sense.
right.
Um,
But then that means that any tokens going from an optimistic rollup to, say, Osmosis, let's say Osmosis is not running a client, or like, some kind of more obscure Cosmos chain, right? It still has to route, like we need routing from that thing to Polymer to the hub to like that other chain potentially. So there's like probably 4 hops to get
yeah.
into Cosmos.
Yeah, but it's pretty straightforward from a technical perspective. The blocker here is multi-hop IBC channels. This is not
Yeah.
multi-hop packet forwarding. Multi-hop packet forwarding is not ideal. Like you don't want to do token transfers like this. You have like you basically have like 4 different like flavors of this token, and you're like transferring it like four
Yeah.
times across 4 different chains. In this model, this is where multi-hop channels make a lot of sense. So you establish a multi-hop channel between the optimistic rollup and the random like SDK app chain anywhere in the interchain directly. So you have this channel, and then you just send the token directly across, and you just have a list of connection IDs beneath this channel.
Okay. Yeah, that makes sense.
Yeah, and you can switch
Okay.
them out. So like, let's say
Yeah.
you wanted to. So like the first connection will denominate the connection between the rollup and Polymer. The second connection would denominate the connection between Polymer and the hub. That second connection, you can even switch. So like, let's say you start with 7 days, like super secure. And at some point, like, oh, maybe the UX isn't that good. We're okay with like 1 day, it's like a more like a 1 day finality, so 1 day wait period for a fraud proof. So you can switch it from like the 7 day client or connection to the 1 day connection. You just do a channel upgrade, and then you'll have like a different path with different security properties. And you can have like different providers too. Like let's say you wanted to like remove the Cosmos Hub as a middle hub. Like maybe the chain decides to implement or like add the Ethereum client support themselves. Then they can remove like hops in the middle as well as the network scales.
Okay. Interesting. And yeah, so this multi-hop channel IBC, like what's the status on that? When do we expect that to be live?
Yeah, so we wrote the spec some time ago. We recently, or semi-recently, got the spec merged officially into the IBC repo, which was
Cool.
it took a long time. There were a lot of reviews. I think it might have had the most feedback out of any IBC spec review in the history of the repo itself. Um, the implementation, we have a POC implementation we're using uh, for like IBC Go. We're using that implementation ourselves. We're planning on upstreaming it, so the IBC Go team has started taking a look at it. I believe they have it planned for Q2 of next year, but I am not entirely sure. But yeah, they have it on the roadmap, and they're planning on upstreaming it.
So just in terms of simplifying like IBC infrastructure in Cosmos, I mean, this would greatly reduce, like if say like the hub and Osmosis and maybe like another handful of really, maybe DYDX, like a handful of really big Cosmos chains, are ensuring connections to lots of different
Yeah,
Cosmos app chains, then say like, I don't know, Juno or Agoric, like they don't have to maintain IBC connections with every other app chain as long as
yeah,
they're connected to a hub that is, providing the connections to those chains. So it removes the burden potentially on sort of smaller app chains to do that work.
yeah, exactly. And then you don't have like this problem of the complexity is going to grow like in a Cambrian sense for operators if you need to maintain direct connectivity between everyone. especially with all the number of like different rollups spinning out. And there will be a lot of these like more like smaller rollups and like roll apps that will need kind of like this connectivity. So I think overall it improves the network topology.
Okay. So one thing that's still unclear is like why build it as a roll up? Why I mean you could have built you could have built an EVM or like an OP stack uh, on top of say the Cosmos SDK or have that work directly with like Tendermint consensus and like a Cosmos validator set, right? Like what was the benefit of bringing it as a roll up? Like do you benefit from being also shared on secured on Ethereum, or does that make it technically easier to implement this? I mean, whereas you could have also just had like an Ethereum client on your Cosmos SDK chain, like Tendermint validator set, right? Like verifying the state of Ethereum and still providing this functionality to EVM chains. But yeah, just curious, like with the
You
sort of like technical reasoning for becoming an OP stack chain.
Yeah, I mean, you could have. The issue with that is that you're changing the trust model of the connectivity for rollups. Like if I'm a rollup builder, the point of building a rollup on Ethereum would be that the rollup is kind of trust minimized in the same domain, communicating between each other. When you
Yeah.
add additional like third party validator set, the trust model now changes. Now you're trusting some like validator set, much weaker security. So like Axelar, Wormhole. I guess a union also is taking this approach. Like without talking about the other properties of these chains, just talking about like just the trust model, and also even like Chainlink CCIP. I also considered kind of CCIP's like Oracle set as like a third party guardian set. So the trust model of this connectivity is less than ideal. Of course, like you can still use uh, like some like third party guardian set for like a soft confirmation mechanism, but the default level of security I think should be like verified by Ethereum in this case. So that's why like but previously when you mentioned that Polymer is like a trust layer, I'm like no, the approach now means that Polymer is no longer a trust layer, which is the whole idea of like why we wanted to do this in the first place. And the idea is that like Polymer is just a feature layer. It's an IBC feature layer, and also like a I guess like router or hub for even like rollups that implement it natively. Yeah, so that's so it's actually it's more work to move this tech
Yeah.
to Ethereum, but we believe it's the right approach.
Okay. No, that makes sense. I think also from a sort of a narrative perspective,
Yeah.
I think there are still a lot of we talked about this earlier. I think there's a lot of challenges still in having IBC being accepted in Ethereum. I mean,
Yes.
because it's a technology that comes out of Cosmos, people associate it with Cosmos.
Yep.
There may be some biases there, whether known or unknown. But I think that it will be a challenge to get IBC to be accepted by teams working on EVM chains. So
Yep.
there's a lot of business development and
Yes.
evangelism to do there. But if you're already being secured by Ethereum, then that trust barrier at least is greatly reduced because
Yep.
you're operating on the same security, you're EVM aligned,
Line.
all those good things, right? That like
Yeah.
people in the EVM world tend to. I really realized this like this week being at DevConnect, just because I don't spend a lot of time in Ethereum so much anymore and going to Ethereum conferences, but there is a real like sense that people in the EVM world and sort of the Ethereum world want to be Ethereum aligned, and being Ethereum aligned, I think, is for you guys like a good way to gain mind share
Yeah,
if this is
exactly.
to be successful. Yeah.
Yeah, you touched on a good point. It's like you need to be able to convince them that this is the right technology in the first place, uh, and make that technology like tangible for this like ecosystem of builders. The other thing that I've kind of noticed is that both Ethereum and the hub have kind of taken a minimalistic approach to the L1. So the hub practices hub minimalism. They don't want to put smart contracts on the hub, so they have Neutron. They don't want to do liquid staking on the hub, so they have Stride. Um, Ethereum, in a sense, has done some of the same from like a scaling perspective. Like originally, they had sharding on the roadmap. They were like, oh well, we have layer twos. Layer twos are going to handle scaling for us. And then if Ethereum's going to kind of just focus on data availability and also offering settlement. And like by them practicing this kind of like minimalistic L1 approach, it means that like if you want to add a feature like IBC, like how would you go about doing that? And like from this perspective, it's like, yeah, well, baking in IBC as a rollup onto Ethereum is essentially enshrining the technology into the Ethereum ecosystem, or into the, not like, into their minds too, but like into the tech stack of like Ethereum.
Yeah. Right. So not enshrining it directly on the L1, but making it available via a roll up,
Yes,
keeps aligned with this minimalistic philosophy with regards to say the hub or Ethereum, but
yes,
still allows EVM chains to interact with IBC. Okay, that's
yeah.
cool.
And this features is still secured by Ethereum stake. So it's like
Yeah.
you now Ethereum has a new feature. It has IBC, and this feature is secured. Yeah, just
So
like how like
so
yeah. So go ahead.
so Polymer will use Ethereum for security and Eigen Layer as well for data availability. I mean, I saw that on one of the slides. I saw the Eigen Layer logo there.
Yeah,
What's the yeah? How's that going to work?
yeah. So the idea is like we want to be as secure, I guess, like as much as possible, like secured by Ethereum stake. And EigenDA being secured by Ethereum stake or restaked Ethereum, kind of works its way in the same sense. I kind of see and it's more. This is more of like a scalability thing. If the costs were lower, we just post the call data to the L1. I think like that's also a viable approach. In fact, that's what we're doing on testnet right now. We're just posting, I would say, the Cosmos transaction data as batch data onto the Ethereum L1 until like the EigenDA testnet is up.
Okay, and so you'll be posting that to Eigen Layer on mainnet.
Yeah, or EigenDA, yes.
Okay, yeah, to Eigen DA. Got it. Yeah.
Yeah, yeah. And EigenDA, I think, has a 10x more throughput than the Ethereum L1, even with proto-dank sharding. So I think there's just more bandwidth as well.
Okay. Um. Yeah. When it comes to the OP stack, you were talking about this canon thing in OP. I'm not exactly sure what it is, but um, you were talking about like the sort of like fault proof system, and you were mentioning some vague acronyms like MIPS and risk V that I have no idea what that means. So, what is all of this about? Because it's like one of the slides in the deck, and just curious why this is relevant.
Yeah, so the relevance comes from needing to prove the validity of the chain. So if you're, and this is probably something that Cosmos app chain folks aren't familiar with, because in the app chain world you have a validator set, and the way you prove validity is you say that these 100 to 150 validators have processed this, or a super majority of them have executed this code using this state machine, and they got the same result. So they can all agree, and we're fine. Uh, on if you're a rollup, the rollup can execute this, but that execution is untrusted. How does the layer one know that what you executed is correct? So there's multiple approaches to this. There's a ZK approach. I think ZK is a bit of a meme now, but it is it does work in terms of verifying that some execution was performed correctly. The other strategy is to use these optimistic fraud proofs. It's to say like you have some sort of like wait period. during which someone can challenge a state transition and say that I was watching the chain and that proposed block that you just made is not correct. But how do you know that on chain? So this is the tricky part. What they found was that you can't just put your application, rewrite your entire application in Solidity and just re-execute a transaction. That would mean like rewriting the entire Cosmos SDK app in Solidity and have the functionality be one-on-one, which it will never be because the internal data structures are different. So this is pretty much impossible. You can't do this. But what you can do is you can say, I can take this program, I can cross-compile this Go program, which is essentially what you get with the Cosmos SDK app chain. Is like you just it compiles down to some code that's run in Go in the Go runtime. So you can cross-compile this Go program into a different instruction set. So you can cross-compile it into MIPS. And the reason why they chose MIPS, I believe, is the MIPS memory and layout is a little bit simpler. Maybe the opcodes, maybe there's fewer opcodes. I think fewer opcodes, like simpler memory layout, is a better fit for this sort of thing. And you can also do RISC-V in the future. Right now, I think MIPS is the only one they actually have an implementation for. So now they've cross-compiled your Cosmos SDK app chain code to this other like instruction set. You can say that I am going to essentially look over. So you have this like list of opcodes, and it can be very large, from the beginning of the program to the end of the program. So you're going to say, I can look for the faulty opcode within any of these opcodes that produced the incorrect result. So a computation is a chain of like I executed an opcode, something changed. Is it correct? So like if you chain all these opcodes together, you get the final result of a state transition. You can play this, they call it an interactive verification game. So on chain, you're actually emulating the MIPS VM in a smart contract, and you're stepping through all the opcodes in a binary search way. So it takes log n steps if the number of opcodes is n. And you just search. You say you go in the middle, you go in, is it left or right, and you kind of just like keep looking through until you find something find the exact faulty opcode. And once you found that, you can say that this shows that fraud was proven. If the end result and the beginning result do not match, at some point there is something something happened that was invalid. If that makes sense.
I'm sure it does. I think it like this flew over my head a little bit, to be honest.
Okay, sorry. Yeah.
but but that's okay. We push the boundaries of like technical explanations here on the show until I start understanding them, and so this is just we just hit one of those boundaries.
Yeah, but it's basically say like you ever played telephone?
Yeah, of course. Yeah.
Okay, so like when you're playing, this is not a great analogy actually, but like technically it's like when you're playing telephone, you're like transmitting the same thing, and you're at some point in the line of telephone, someone's gonna like mess it up and be like, now the result is gonna be incorrect. So like you start with an elephant and you got like a donkey, and then who along this list like line of people like communicated the wrong thing or communicated something incorrectly so that like the end result was donkey. Because at some point people started thinking it was a donkey, and then like the list of opcodes is kind of like that. It's like at some point there's an opcode that like completely did something like undefined. Actually, it wasn't respecting the behavior of the VM. It just did like from here to this step, this step, this step, this step. I just I changed it. I went from an elephant to like a donkey, like another animal. So like that's kind of like the analogy in my head.
Okay. So, you also talked about this Monomer SDK. So what's the idea here?
So the reason why we named it monomer first off was a polymer is formed of multiple monomers. So if you can think of a polymer connecting the Monomer SDK can build these app rollup chains that are like Cosmos SDK app rollups on Ethereum, but you can think of polymer as like if you compose many monomers together connected by polymer, they become a polymer. So
Oh,
that's kind of like the thinking
clever.
behind the naming. So Monomer SDK is just a combination of two different frameworks, Cosmos SDK and the OP stack. The idea is that the OP stack itself, lacks, as we discussed earlier in the podcast, kind of lacks this customizability. It's kind of hard to build like your own custom app rollup. It's pretty easy to just build another EVM rollup and then deploy smart contract on it. But maybe not everyone wants to do that. Maybe some people want to, make some optimizations that are like application specific. So to actually be application specific, which framework has the best developer UX, community, docs, in globally speaking? And I think that's Cosmos SDK. I'm a little bit biased, but I think some of you is probably biased here as well. But the Cosmos SDK arguably has one of the best, if not the best, dev UX. If we combine the best dev UX with like the settlement features of the OP stack, we can address a much bigger market and we get much greater distribution for the Cosmos technology. And long term, it honestly makes more sense to me that I would expect to see more like Cosmos SDK, like or like basically Monomer SDK rollups than just generic like EVM, like some random virtual machine with a smart contract on a rollup, because like these like VM rollups, they're not differentiated. There can only be so many of them. Like at what point does a like 50th EVM rollup become like not that interesting?
Yeah.
So I
What
can't
you're
expect it.
saying is that rollups will be applications, basically. Like each rollup will be an app.
Yeah, like application specific rollups. I think long term
Yeah.
we'll see a lot more of that as like these applications want to differentiate and want to specialize.
Yeah, and as long as like OP stack is sitting underneath it, providing some sort of composability, or like IBC is exists between all of these rollups, either via Polymer or just by the fact that these are using Monomer and IBC compatible out of the box, then applications can be like rollups can be applications in the
Yep.
same way that we have websites, and those are like sovereign applications to some extent, right? Like in containerized applications, and we
Yeah.
don't need like another roll up with a bunch of apps on it. Like each app can sort of like be each roll up can be an app.
Yeah. So I guess like my mental model there is like, do you want a so some applications like are okay being co-located, like co-hosted. So in different cloud services, you can have
Yeah,
like many different like Docker containers essentially
yeah,
share the same hardware.
yeah,
But some applications want to be like by themselves,
yeah,
and like they want the performance, or they want to kind of like be more specialized doing something.
yeah.
The bare or like just be bare metal. Um, in those cases, like I kind of see like those as being kind of like different. So like you have some like stuff that's co-located, some stuff is going to be I guess like deployed or like bare metal essentially.
So the Monomer SDK will have it's the Cosmos SDK with all of its modules, and it's sitting on top of the OP stack. And so instead of having Tendermint consensus there, it has the OP stack where it's like committing to the OP stack.
Yep.
So it can have governance. It can have like it can create tokens. It has like
Yep.
all the functionality of the Cosmos SDK. I
Yes.
guess maybe like the staking module is no longer necessary, or like what about the
So so
modules that are kind of specific to the fact that we have a validator set?
you can actually have both, uh, and this is an interesting concept. So I was planning on writing like a blog post exploring this, but I kind of see like the ABCI boundary as having like the ABCI client being on the OP stack, side of the boundary, the ABCI server being the Cosmos SDK app chain on the other side. I actually see there being multiple, I would say like apps or ABCI servers and multiple ABCI clients running at the same time. So I can see OP stack and Comet BFT running at the same time. The Comet BFT would provide kind of like what I mentioned earlier, like this like soft could potentially provide soft confirmations. And I'll say the Cosmos SC, sorry, the OP stack is then providing settlement logic. So you can still have like a staking module, except the staking module is like staking for pre-confirmations instead of like staking for like final security. So final security is Ethereum. So like there's like a lot of like hybrid things you can do, and I think like long term there will be a lot of like this whole thing is in the concept of like a blockchain operating system.
Yeah,
So what is a blockchain operating system? What does it look like? What are all the components? To me, like a blockchain operating system in the sense of a rollup is you have like many kind of like client side things which act as like the blockchain kernel, and you have many like
Yeah.
application side things that act as like the blockchain user space. And the two of those will kind of interact. You have like a bunch of stuff in the user space, like it might be one Cosmos SDK app chain, it might be that plus IBC, and then on the other side, it might be like OP stack settlement, and like common BFT or some other consensus mechanism, and so on.
Hmm. Interesting. What's the go to market here? We talked a little bit about this earlier, like the challenge of building IBC mindshare within the EVM Ethereum aligned community. How do you plan on doing that?
Yeah, I think it's going to be from I think with BD there's two strategies. There's like bottom up BD and there's like top down BD. In my mind, the way I think about like top down is like your applications. So it's BD directly with applications, like why they should use IBC, like how's it different, and so on. Bottoms up is from the infrastructure layers. Even by putting IBC onto Ethereum in the form of rollup is a form of bottoms up BD. Getting distribution into additional rollup frameworks on Ethereum is also bottoms up BD. I think even Monomer SDK is bottoms up BD, meaning that the more like natively interoperable IBC rollups on Ethereum kind of spreads that IBC mindshare. So those are the kind of like two like dual sided funnels that we need to work on.
Okay, yeah, I mean this is really cool. I mean, because I feel like it merges Cosmos and Ethereum in a way. We can now, with Monomer SDK, we could have Cosmos applications in Ethereum. You provide a way for people to experience Cosmosm, but secured by Ethereum chains. Yeah, what do you see as the future here in terms of converging Ethereum and Cosmos, and what's the role of Polymer there?
Yeah, I kind of see Polymer as being the catalyst or trying to catalyze the merge, like the literal merge of the two ecosystems. I think people have been talking for some time about like Cosmos and Ethereum kind of coming together. I think like merging at this with this at this interface at kind of like this ABCI interface, it merges the technologies very much in a literal sense. So it's like the real merge wasn't like Ethereum's kind of I guess a consensus and execution layers merging in like Ethereum, I guess, 2.0. This is the real merge is between the two ecosystems. Essentially, you have like this growth actually of the interchain. Like Ethereum itself kind of becomes a part of the interchain, and the interchain just expands. And like this is I think a big step in the direction of, and I think we have to get here, a big step in the direction of at some point builders they can't and users can't know like which ecosystem they're interacting with. Like they cannot. Like if like me as a user had to be like, oh, I'm using an app, do I connect to Google Cloud or do I connect to AWS? like like that is like absurd. Like no app works like that. So like Polymer can kind of help like form this like unified API, so and also like merging the two tech stacks together and technologies together, so we kind of have this like uniform like Web3 like API for builders, for I guess like applications building on top to be able to deploy anywhere and just not have to worry about whatever specific ecosystem that they're like stuck in. Essentially, no one's stuck. Everything's seamlessly interoperable.
That's the future. Everything is
Yeah.
seamlessly interoperable. Or at least it feels like we're on the cusp of getting there.
Yeah.
I'm really hopeful that in the next 3 to 5 years, that this interoperable future that we've been talking about for years will become a reality, and I think that with technologies like this and like other interoperability solutions that are innovating
Yeah.
on all sorts of fronts, right? And like we've had a lot of them on here on the podcast.
Yeah.
I didn't want this to be an interoperability podcast, although it is called the Interop. I was like, that wasn't the idea, but it just feels like
Yeah.
there's just so much innovation happening in this vertical that it's interesting to sort of like get everybody and just look at all the different approaches. But I like this approach. I think it's like an IBC vampire attack on Ethereum.
Yeah, yeah,
You know, yeah. What's the road to mainnet?
yeah. So we're currently targeting testnet in December. We'll probably privately onboard some partners then. We'll most likely like announce that in January or so. Just because December is kind of like a dead time for this sort of thing. And then in terms of the mainnet launch, we're targeting Q2 of next year.
Cool. Bo, thanks so much for coming back on again. It was great. I love diving into this kind of stuff. And thanks for having me at the IBC Summit. I really enjoyed our panel there. I think people will want to check that out once it's live, once it's on YouTube. I did a panel with Carell of Union and you, and it was spicy at times, but it was really fun. So really enjoyed that as well.
Yeah.
Thanks so much.
Yep, awesome. Thank you.